because there's some ors and ands. Let's talk about one. There's our flock now. We added March. Or maybe Matt. We'll have to see here, won't we, right? Right? So here we go. How many ways can you have two girls, which implies one boy? Well, either Bertha is a girl, and Marge is a girl, and Nancy's a boy, or Bertha's a girl, and Marge is a boy, and Nancy's a girl, or Bertha's a boy, and Nancy and Marge are girls. And there's three. Are there any other possibilities? Nah, there's three birds. One of them has to be the boy. It's either Bertha or Marge or Nancy. So there's three ways to assign that roosterness to one of the birds. Now once you've assigned the rooster, do you agree the other two have to be girls? And it doesn't matter how you order them because they're already there? Hopefully that makes sense. You just have to put a dot on one of them. You're the boy. The other two are by default girls. Go, Candace, ask me that question.
Yeah, I'm just thinking about how you apply that now to...
Oh, you got it. So one way of doing it, there's actually two ways. I like to champion one way if it's okay. So Candace's way of how to apply that to here. We could, don't write this, but we could do it this way. 0.9 times 0.9 times 0.1, or 0.9 times 0.1 times 0.9, or 0.1 times 0.9 times 0.9. Now that's correct. It's also a little bit overbearing and overkill. Why don't we just do this, Candace, instead? Aren't all of these equal to the same numerical value? Let's just put a 3 out front. Times by 3, which is the same as adding the same thing 3 times. Is that fair? Now, hopefully that makes sense, yes. This is why we're building the flock one bird at a time, to make sure we understand why those numbers are going out front. I have a whole quiz for you guys, if you choose, next week, based only on those numbers. Because they're very, very special in mathematics. You've already seen one already, you're going to see more, you're going to see more when we build my flock of 4 momentarily for your in-class quiz. Good. And that ends up being, let me see, that's 0.243, is that right, Tom? Mm-hmm. You crunched already, right? Look at that, holy crap. That's a high probability, isn't it? That's like 1 in 4 times. So if I send Max into the store 4 years in a row and have him buy 3 chickens each time, that tells me on average I can expect in one of those 4 trips to get a boy in that box. That could have been why Fern got killed. She may have been a boy and Mary's like, maybe. I mean, I will never know because we didn't autopsy her because some damn raccoon stole her in the night. We buried her in some... It's amazing. We bury our dead pets in the backyard because we're freaky. And something always digs them up. I cover them with rocks. I put traps over them with like large rocks to fall on the hole if something digs them out. And what I'm guessing it's a raccoon. I'm assuming it's a raccoon or an ogre. Something gets to them. And I go out there's a big hole, the rocks trip, body's gone. All right, sorry, didn't come here to tell you that. Pick another one. Up to you. What are we doing next? 0. I'm surprised we didn't go to 0 next. That's one of the nicer ones, right? Yeah, Teresa, what is it?
0.0000001.
I'm just going to show you the calculation too. It's 0.1 times 0.1 times 0.1 because you have to get 3 roosters, right? Is that fair? You didn't do that? Well, tell me what you did. Tell me what you did.
I don't remember what I did.
Oh, damn. That's okay. Well, you did this. Beautiful, beautiful. Thank you, sister. So you have to get a rooster, and then a rooster, and then a rooster. Is there any multipliers? Is there a 3 to go out here? No, because there's no uncertainty as to where the boys and girls are. It means Bertha is a girl. Bertha is a boy, Marge is a boy, and Nancy's a boy. They're all boys. If you want to put a number there, put a 1 there. You don't have to. There's only one. It's like rolling snake eyes with 3 dice. 1, 1, 1. Done. So that's only a 1 in 1,000 chance, isn't it? So I wouldn't worry about that. Candace, go.
This might take too long to explain because I missed
Please,
it, but if it's just really quick,
No,
where did the
please.
0.1 and 0.9 come
It's
from?
okay. When I walked in, you missed the story.
I know.
The story, it's okay. The story was when we bought the birds, I asked them how they know they're girls. The answer was they don't, but they're 90% likely to be girls.
So it's a set number.
It's a set number.
Okay.
They told me 90%, which means 10% of them are roosters.
Okay.
Is that fair?
Yes.
Thank you. That's all you need to know. And
Okay.
it's important. It's called a parameter of the distribution.
Okay.
There are 2 parameters of distribution. One is how many birds we bought, which is 4. And the second is what's the chance of one of those being a girl, which is the 0.9.
Okay, and was the years significant when you mentioned over 4 years? Is that a significant
Oh,
number?
all I'm doing, thank you for that question, a very good question. All I'm doing there is I'm trying to give you some idea of how high this probability is. So with this is about 25%. which is about 1 in 4, 1/4 as a fraction.
Okay.
Which means out of every 4 years, if I send Max in to buy 3 birds every 4 years, I can reasonably expect about 1 out of every one of those 4 years, he's going to come out with 2 girls and a boy.
Okay.
Now, think about that more macro. How many birds has he bought after 4 years in that way? If he buys 3 at a time over 4 years, how many birds do we have in our flock now? Assuming they all live. 12. Well, if 90% of the birds are girls, doesn't that mean we should expect one of them's a boy by now? Because one of them should be out of 10, 1 out of 10 should be a boy. So by the time 4 years comes around, probability's caught up to us, and we got our boy. It's fair?
Yeah.
So that's all I'm trying to do is I'm trying to say this is why I was so nervous at that checkout desk. Because these were starting to get a little bit bigger than I cared for, right? And then you spend 6 months going, don't crow. Watching the back of their feet to see if the little spurs, that are called spurs, start coming out. And then I hear the crowing from the backyard. That's what I've been hearing over the past couple weeks. I don't like, oh shit, she is a rooster. We'll come back to that in a second. So now we know what the last one has to be, don't we? That's 73. That's, hang on, because I'm just in my head. 73, 97.3 would be 2.7. Is that right? Yep. I did that right in my head. Okay, good. Now again, the question that Eric and Tom both asked before is, how could we have gotten that without knowing the other 3? Could we have calculated it? Say yes. Of course we could, right? Put the 0.1s and 0.9s together. Put the 0.1s and 0.9s. Go ahead, Candace, go!
Would you have done the same thing and times it by 3?
You have to, don't you?
Okay.
Here's why. Here's why. Oh, here's 2 reasons why. One's kind of lame and one's great. First, if you have 1 girl, that means you have a girl and then 2 boys. If you multiply that out, that's 0.009. That's not enough. So that's the lame reason. It's not enough. It's 2.7. Then you got to realize if you've got 1 girl and 2 boys, which one's the girl? You've got 3 dice now, and 2 of them are 1 and 1 of them is a 2. Which one's the 2? It could be the green die or the yellow die or the red die, which means it could be Bertha or Marge or Nancy. Is that fair? Yeah. So it's got to be 3 out front again. There's a beautiful symmetry in those numbers. After the next flock, you'll never have to worry about them again, because that's what the programs I gave you guys at the beginning of class take care of all those calculations for you. I'll explain it to you on Tuesday next week. We'll explain it to you on Tuesday next week. It's not important to know right now. It's the shortcut. I don't want you to know the shortcut today. I want you to know the inner workings today. Okay, on average, how many girls we got? Want to do it one more time by hand? I mean, you guys understand, you see how it's repetitive. It's very repetitive. We're doing the same calculation over and over again. Hopefully you're catching that. I think you are. Good. So, how much of a girl gets contributed by the all roosters case? None. It only happens 1 in 1,000 times, but nothing gets contributed. We're talking about, you have to think of this average as, I'm going to stop talking. I just got a beautiful vision in my head. It's going to confuse the hell out of me, so I'm going to stop talking. Basically, we have to put the average together. Each of these pieces contributes something towards the average. Which piece is each? This contributes nothing. How much does this contribute? Well, it only happens 2.7% of the time, which makes me not worry about it all that much. That means it contributes very little bit. Very little bit. 1 times that is a very small chunk towards the average. Then we got 2 times 0.243. That's contributing about half a girl. That's about a quarter. Times 2 is about a half. That's about a half of a chicken, or half of a female. Huh? But the big contribution comes down here. 729 times the 3. What does that all work out to be? Oh, you guys are still working. I'm sorry. You guys are still working. What do you guys get? Eric. 2.1 something?
2.7?
2.7? We got 2 people. I heard a stereo. 2.7?
Yeah.
2.7 is that sound? Oh, it's close.
Point.
Let me take a quick look. Quick look. That beautiful. Plus the 0.48, which is that. Yeah. Oh, it's 243. There's an extra little bit of 3 in there. Yeah, and that's okay. Don't you worry about it. Don't you worry about it. I heard a 2.7, 2.7. You know what? Let's put it together. Hang on. Let's grab Google. And again, this. If you understand where the distribution came from, that's the important thing. This calculation is very, very much an after-the-thought kind of thing. 1 times 0.027, right? Yes? Plus, I'm leaving the 0 off because it doesn't give you anything anyway. 0.243 plus 3 times 0.729. Yes, yes, yes. I get 2.7. And a strange link to the Sage Encyclopedia of Social Science Research Methods, whatever. So 2.7. 2.7 birds per flock. Now, let's think about this. Could we have known that average without doing all that calculation? Remember, I'm deceased. How do I view that little peeping thing in that bin?
0.9 of a girl.
That's 0.9 of a girl. Max grabs 3 of them. What's 3.9s of a girl? 2.7 girls. Does that make sense? Every time he grabs a bird, I'm like, okay, grab another one. That's not enough eggs. Right? Every time he's grabbing 0.9 of a girl every single time. Now, you can't do this with every distribution, but it works beautifully with this one. When there's 2 outcomes like that, he's grabbing 0.9. He's also grabbing 0.1 of a rooster on average. Because right now, we're averaging 0.3 roosters. Does that make sense? We're averaging 2.7 girls and the other 0.3 of the roosters. So every time he grabs a burrow, I'm like, it's going to be a half soon. We got 8 birds in our flock until someone got murdered. That means I have 0.8 of a rooster in my shed. After 8, right? After 8 birds, I got 0.8 of a rooster. That's getting very close to 1. They're making me very, very nervous. Now, fortunately, Mary killed 3 of them, so don't worry about it. But you know, I'm still worried about, as he's grabbing birds, it's still the most likely that we're getting all girls. It's just that that's starting to drop off exponentially, so to speak. Questions? Comments? Concerns? One more? Let's make it an in-class quiz. Rip a piece of paper out of your notebook. Let's do it together. We'll have you turn it in.